We are factoring trinomials, perfect square trinomials. Okay, so the things you need to know, you're always double checking for a GCF. That is something you should always do forever and ever, pretty much from here on to the end of the school year. Okay, always check for a GCF. The first and the last term must be perfect squares, because we're literally talking about perfect square trinomials. Okay, trinomials means 3 terms. Okay, so the first and last term must be perfect squares. The middle term equals 2 times a times b. And I know this is weird because we were used to saying a, b, c, right? But we're not really looking at it like that right now. We're looking at a and b because we're just trying to find that first and last term. That's all we're worried about. Okay, so it is a little different in that aspect, but don't let it stress you out. So there's a sum and a difference. You're only looking at that first sign because 2 negatives makes a positive. So that second one will always be positive. So if it's a plus at the beginning, it's a plus in your parentheses. If it's a minus at the beginning, it's a minus in your parentheses. One thing I do want to show you is from last packet. Perfect. Y'all have done perfect square trinomials. Y'all just did the box for them. This is a perfect square trinomial. This was on the practice. Okay, perfect square trinomial just means your answer is a perfect square. Yes? This is from this class. Did you learn it? Yes. The box? Yes. I taught it to y'all for your last test. Yeah. Okay. A little behind. So that's what we're doing here. However, you do not have to do the box on these because I'm teaching you a different method. So the only reason you need to know about the b term being 2 times a times b is just to check if it's a perfect square trinomial. So what squared gives you x squared? Well, that's pretty simple. Isn't it just x? Okay, so this is just x. And then what squared gives you 36? Well, this yellow card on y'all's desks, you're only looking, like pretty much the only important part is this first little left piece of it. The rest of that's not important to you yet. We'll get there, but it's not yet. The only pieces we're looking here because these are squares. Yours doesn't say 1 squared equals 1, but I did write that there earlier today because it's good to know. Okay, so knowing that, what squared equals 36? Well, it's just 6 squared, right? Well, I want y'all to realize that a is whatever's squared in that first piece. So a is just x. And b is whatever's squared in that last piece. So it's just 6. Yes? So to double check that this is a perfect square trinomial before I say what the answer is, a times b, what's 6 times x? 6x times 2. Did it work? So 2 times a times b did give me my middle term. So here's my answer. Well, this is plus plus, so it's going to be a sum. What's my a? Plus, what's my b? And then I put a squared on the outside. There's your answer. Yes? Okay, let's look at number 2. What do you notice right away? It does have a number in front. What else? Does it have a GCF? Yes. How do we know right away? They're all even. Okay, if all your numbers are even, that means you have a GCF of at least 2. Okay, so we could double check if 2 is our GCF. You could do math, right, 9, 18, 24, just your first 2 numbers, because remember, you can only type 2 at a time. And it tells me 6. Does 6 go into 8? No, not pretty. Okay, so we're going to type our first GCF, comma, our third number, which is 8. So my GCF is just 2. Okay, so I'm going to take out the 2, and I'm going to divide it out. That leaves me with 9x squared plus 12x plus 4. Now, I don't know if you remember from before this long weekend, but anytime I had a GCF out front, we put it at the bottom where we were going to write our answer, and we crossed it out so it doesn't throw us off. Yes? Okay, so knowing that, what squared gives me my first and last term? 3 what? No. What about the letter?
Oh, 3x.
3x. Yeah, so 3 squared is 9, x squared is x squared, so that worked. And what squared gives me 4? 2. So I know that A is just 3x and B is just 2. Now, is this going to be sum or difference? Sum. So then it's just, but before we do that, we need to check that this is a perfect square trinomial. What's 3x times 2? Double it. Did it work? So this is a perfect square trinomial. So it's 3x, 2. Any questions with those two? Okay, let's look at the next two. Let's look at number 3. What's weird about number 3? It has subtraction. What else?
The middle number and the exponents.
The exponents are different. What are your exponents? M is your variable, and our exponent is 4. Okay, our main exponent is 4 and then 2. Okay, that's okay. As long as it's an even number, it's a perfect square. Because power to a power, if we rewrite this, just like we have, there's no GCF here because our last term is 1. Okay, so I could take a 1 out. Does that change anything? No, so don't waste your time. Something squared, something squared. So what squared gives me 4? Let's start there. 2. What's half of 4? So you can always just cut your your exponent, in half, and it'll tell you what goes on the inside. Because 2 times 2 is 4, does that work? Yes. So A is just 2m squared. What's B? 1. Okay, what's 2m squared times 1? Times 2? Did it work? Yes. So this is a perfect square trinomial. Now, is this going to be sum or difference?
Why is there a square inside the 2?
Because it's to the 4th power.
Oh, okay.
So 2 times 2 is 4. We have to make it equal, but we're looking for what's squared because that's what this is telling us to do. Okay. So sum or difference, difference, because that first one is subtraction. So A minus B, and then the whole thing squared. So the only time you'll have an exponent on the inside of your parentheses is when your exponent to start was bigger than 2. Yes? Okay. Any questions with that? Okay, let's look at one more. Look at number 4. Is there a GCF? Yes. What is it? 2x. Not just 2, not just x. It's got both. First off, it has a cubed. Okay, perfect square cannot be to the 3rd power. Okay, because up here when we head to the 4th power, that's m times m times m times m. So you had 2 groups of 2. That's why we could do that. Yes? But when you have 3, can you cut that in half to be exact? No. Okay, so this doesn't even work. But if I take out an x because all 3 terms have an x, it might work. And so it does have a 2 in common because they're all even. That tells you that. So we could take out a 2x. Eight divided by 2 is 4. And then remember, you subtract your exponent. So this is 3 minus 1, which leaves you with x squared. Minus 40 divided by 2 is 20. 2 minus 1 is just 1. And then plus 50 divided by 2 is 25, and these x's canceled. Now, when I have a GCF, do not forget to write it down at the bottom with your answer. Because that's honestly the biggest mistake I've seen today is just people forgetting to bring down their GCF. And the second biggest mistake is not paying attention to whether it should be plus or minus, people just putting plus for all of them. Okay, so take down your GCF and then cross it out so you don't let it mess you up. Are these first and last terms perfect squares? Yes. What times what gives you 4x squared? 2x. And then what times what gives you 25? So I know that A is 2x and B is 5. Now, what is 2x times 5? 10x, and now double it. Did it work? So this is a perfect square trinomial, so I'm done. Is it going to be minus or plus? So A, no, you were right. First term's minus. So 2x minus 5, and then the whole thing squared. And then don't forget your GCF in front. That's honestly it.